Hello and welcome back to Gaffy's Grinds. My name is Mr. Gaffy. This is a Leaving Cert Chemistry video trying to take difficult concepts from Leaving Cert Chemistry, break them down, help you to understand them, and then give you some practice to do. Okay, so this we're currently doing some organic chemistry, and this is organic chemistry video 6. If you haven't already done organic chemistry's videos 1 to 5, it's really important that you do them in order, otherwise this isn't going to make any sense. So go back and look for videos 1 to 5 and watch them in order. Some tips on using these videos. Again, as I always say, get rid of all distractions. So turn off your phone or else put it in a different room where you can't be tempted to pick it up, and close any other tabs that you have open if you're watching this on your laptop. Again, any notifications are going to distract you, so this just stops that from happening. The most important piece of advice I have is that I'm going to get you to do some questions to practice. Practice makes permanent. So when we do practice and make sure that we learn stuff, we practice retrieving information. If you don't do the practice, guys, you're wasting your time watching these videos. You're not going to learn as much. So make sure that when I ask you to pause the video and do the practice, that you do it. In the last video, we learned how to name some alkanes. When we were given the displayed formula, we learned how to name some alkanes. Okay. Very quickly, I'm going to give you an example to do, just as a recap. Okay, so just as a recap, I'm going to give you a practice question to do. This is a naming question. So what I want you to do is I want you to name the following compound. Okay, you can assume that at the end of each of these bonds, where I'm not drawn in, where I've just drawn a line, that you would have hydrogen. Okay, so what I want you to do is I want you to pause the video and I want you to write down the molecular formula of this structure, and I want you to write down the name. Okay, so pause the video and do that now. Okay, so you should only be watching the video if you have tried to do this question. Okay, so first of all, I'm going to write down the molecular formula. So the molecular formula just tells you which type of atoms are here and how many of them there are here. Right, so the first thing I'm going to do is I'm going to count. I know I have carbon atoms. 1, 2, 3, 4, 5, 6, 7, 8. 8 carbons, so C8. C8, and then the rest are hydrogens. 1, 2, 3. 1, 2, 3, that's 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17, 18. H18. Now that fits the general formula, CnH2n plus 2. So that tells me, so I'm just going to rub this out so it's a bit more clear. It's C8H18. That fits the general formula of an alkane. So this is going to be an alkane. Now, the next thing I'm going to do is I'm going to count. So for the naming, I'm going to count the longest carbon chain. And the longest carbon chain is this one here. 1, 2, 3, 4, 5, 6. There's no other carbon chain that's longer than this. There is 1, 2, 3, 4, 5, 6, which is the same length. There's 1, 2, 3, 4, 5, that's not longer. So 6 is the longest carbon chain. And because it's easier to work with the straight one, I'm going to take this 6th one. Okay. Now, so that tells me I'm going to write down the parent name. It's going to be hex for 6. And I know it's an alkane because it's got all single bonds. So it's all saturated bonds. So it's going to be an alkane. So that means the parent name is going to be hexane. Hexane is the parent name. Step 2 is I'm going to number the longest carbon chain and starting at the end, which is going to give me the lowest number on the branches. So I could start at this end, 1, 2, 3, 4, 5, 6. But that gives me a first number for a branch of 3. If I start from this side, 1, 2, 3, 4, 5, 6, then I've got the number 2 on my branch. So that's, if I start from this side, it's going to give me lower numbers on the branches. So that's what I'm going to do. 1, 2, 3, 4, 5, and 6. Okay. The next thing to do is identify which branches they are and on which carbons are they on. So first of all, I can see that this here is a methyl group because it's 1 carbon, methyl. Okay, so I've got a methyl group, and it's on carbon 2. on C2. And I've got another methyl group on carbon 4. Methyl group on carbon 4. Okay, so I need to indicate, first of all, using numbers, the carbons that the branches are on. So it's going to be 2, 4, because I have one on 2 and I have one on 4. Then I'm going to use a dash to separate numbers and words. So 2, 4, and because I've got 2 methyls, it's going to be dimethyl hexane. 2, 4, dimethyl hexane. Well done if you got that right. I hope that you did. So 2, 4, dimethyl hexane, and has a structure, a molecular formula of CH18. Okay, so that was just a quick bit of revision. Today we're going to learn how to work backwards. So if I give you a name, you're going to learn how to draw the alkane. Okay, so I'm going to do quite a difficult example. I'm going to do what I think is the most difficult example that you might come across. And then once you've seen me do the most difficult one, then the other ones that you practice afterwards should be easier. Okay. Now, so we're going to practice name the, oh, sorry, we've already learned how to name. We're going to draw, sorry, we're going to draw the structure of, okay, so I'm going to give you a name. I'm going to show you, we're going to get a name and we're going to draw the formula. Okay, so draw the structure of 3 ethyl 2 5 dimethyl hexane. Now that is quite a mouthful. Let's just break it apart. I've got, on carbon 3, I've got an ethyl. On carbon 2 and carbon 5, I've got di, so I've got 2 methyl. So I've got a methyl on carbon 2, and on carbon 5, and on carbon 3, I've got an ethyl. And hopefully there you can see the parent molecule is hexane. Okay, so how do I approach doing this? All right, well, step 1 is parent molecule. Identify and draw the parent molecule. Okay, so what we want to do is we want to basically draw a straight chain for the parent molecule. So the parent molecule is here. It's hexane, parent. Okay, so hexane, what I'm going to do here is I'm going to draw 6 carbons in a straight chain. 1, 2, 3, 4, 5, 6. Now, the same way I would when I'm trying to name it, I'm going to number this longest chain. 1, 2, 3, 4, 5, 6. Now, it doesn't matter which side you start on for numbering this because you haven't put the branches on yet. So you can start from either side and it won't make any difference. So there is my longest carbon chain, my parent molecule. Okay, step 2, branches. So we have to put the correct branches in the correct positions. Right, what do we know? We know, just as a rough work over here, we've got an ethyl on C3. So ethyl on C3. That's what that means. Carbon 3, I've got an ethyl. On carbon 2, one of the methyls. So I've got dimethyl 2. On carbon 2, I've got a methyl. So methyl on C2. And on C5, I've got the other methyl. So methyl on C5. Okay, so next thing then is to draw the branches in. Okay. Right, so ethyl on carbon 3. So here's carbon 3. I've got an ethyl group on carbon 3. Now, ethyl, eth means 2 carbons. So it's going to be a carbon chain with 2 carbons, C2, H5 is an ethyl group. And if you weren't sure, I would draw out the 2 carbons in the chain. Okay, so I would draw out 2 carbons and see how many hydrogens can fit on. But you should know by now that ethyl is C2H5. I've got a methyl on carbon 2. Here's carbon 2. It doesn't matter whether it's above or below. I'm drawing it below because it'll be clashing with the one above if I draw it up there. It's just easier to fit it in here. Okay, so methyl, the formula is CH3. And again, if you weren't sure how many hydrogens you can put on, draw the carbon and see how many bonds are left on the carbon. That'll tell you how many hydrogens. And I've got another methyl on carbon 5. So here is the other methyl, CH3. Now, step 3, and this is the tedious bit, hydrogens. Hydrogens. Okay, so fill in any carbon that doesn't have bonds. I'm going to fill in hydrogens. Well, this carbon has no bonds, so that means we can put 3 hydrogens, H, H, H. This carbon has 1 bond here, 1 here, and 1 here. It can have 4 altogether, so it's got another hydrogen there. This carbon has 1, 2, 3 bonds, it's got 1 hydrogen down below. This carbon has 1, 2 bonds, so 1 hydrogen above and 1 hydrogen below. This carbon has 1, 2, 3 bonds, so it can fit 1 more like that. This carbon only has 1 bond, so 1, 2, 3 hydrogens. Okay, so that is the correct structure for 3 ethyl 2-methyl, 3 ethyl 2,5-dimethyl hexane. Okay, so what I'm going to get you to do now is I'm going to get you to pause and take that down in your notes copy as an example of how to draw the structure. So you might just say how to draw alkanes, and I have given you steps to follow to make it easier for you, reduce your cognitive load by giving you steps to follow, and also I have given you one of the more difficult examples, and if you can follow that example, then the rest should be easy enough. Okay, all right, so pause the video and take that example down. Okay, so we should be playing the video now. If you have actually paused the video and taken down that example, it's time for you guys to do some practice. All right, I'm going to start off with a few easy ones. So you draw the structures of these compounds now, please. So pause the video and draw these structures. Okay, so you should be watching the video now if you have completed each of those. Okay, so what we're going to do now is I'm going to go through the answers. It's best if I just draw them out live for you so you guys can see my thinking on it. Okay, so I'm just going to stop share and you should see the board again. Okay, so the first one, A, was methane. Methane. Methane looks like this. 1 carbon, meth. It's an alkane, so all single bonds. So 1, 2, 3, carbon can form 4 bonds. So with all hydrogens like that, that's methane. B, ethane, 2 carbons, C. It's an alkane, so it's C single bond C, and then fill in the hydrogens. Well, each carbon can have 4 bonds, so 3 hydrogens on this one, and 3 hydrogens on this one. That's ethane. C, propane, 1, 2, 3 carbons in a chain, and each carbon can have 6 bonds. Sorry, 4 bonds, excuse me. Hydrogen, hydrogen, hydrogen. This one can fit 2 more hydrogens, and this one can fit 3 hydrogens. That is propane. Okay, butane, D, is but means 4, so 1, 2, 3, 4 carbons in a chain. 1, 2, 3, 1, 2, 1, 2, and 1, 2, 3. All hydrogens. This is butane. Okay. E is pentane. Pent means 5 carbons, so 5 carbons in a chain, like that. And all hydrogens. I'm not going to stick them in. I'm just going to draw lines. You know, each of them is a hydrogen. That's pentane. F is hexane. 6 carbons in a chain. Sorry about that. 1, 2, 3, 1, 2, 1, 2, 1, 2, and 1, 2, 3. That's hexane. The last one in that set was cyclohexene, G. Okay, so cyclohexane, that means we have a cyclic compound, so it's circular. So we have 6 carbons, but they're in a chain. So we need to make a hexagon shape, like that. And each of them, you see each of these carbons already has 2 bonds. That means they've got 2 more hydrogens stuck on, like that. I'll put in the hydrogens because this one is different. Okay, so these are all straight chained alkanes. We kind of covered that already, so that should be easy. This is cyclohexane. Okay, now some of the examples are going to get a little bit harder now. Now, before we go on to some more complicated examples, I just want to remind you of the branch, some of the branch names, just this one. Okay, so if you see a Cl attached on a particular carbon, then we give it the name chloro. So where would be an example of this? Well, if I was to say, have a 3 carbon chain, and all of these are hydrogens, but this one in the middle is a Cl. Okay, well, this is the parent molecule of 1, 2, 3 carbons. So it's going to be propane is the parent molecule, propane. Step 2 is to identify the branches. I've got a Cl, that means I've got a chloro branch. Okay, so I've got a chloro branch and it's on carbon 1, 2, 3. So it's on carbon 2. So chloro on C2. Okay, so I have to account for that over here. So this is going to be 2 chloropropane. 2 chloropropane. That's how I would do that. Okay, so just be wary of that when we go into practicing these examples. Okay, so these are your practice questions. So what I want you to do is I want you to pause the video and I want you to try each of these questions now, please. Okay, so you should have paused the video and tried those questions. You should only be watching this video if you have made your best effort at them now. Okay, so again, I'm going to draw these out. So the first one is 2-methyl pentane. Okay, so I'm going to write down the name, 2-methyl pentane. Okay, so step 1 here with 2-methyl pentane is we're going to take the parent molecule, pentane, and we're going to draw it out. So we've got pentane, that pent means 5. Alkane means all single bonds. So 1, 2, 3, 4, 5. Number carbon chain, 1, 2, 3, 4, 5. Okay. Next thing is work out the branches and the carbons are on. So I've got 1 methyl group. It's not dimethyl, it's just methyl. I've got a methyl on carbon 2. So this 2 means that the methyl is on carbon 2. Okay, so I'm going to draw that here. Here is my methyl group. Okay. So step 1, if you remember, was parent. Step 2 was branches. And step 3 was hydrogens. That was the steps I told you to follow. So I've got my branches on carbon 2. Now to fill in my hydrogens. 1, 2, 3 hydrogens here. Hydrogen, hydrogen, hydrogen. This is a methyl, so it has 3 hydrogens. CH3 is a methyl group. This carbon now has 3 bonds, so I have to give it another one, another hydrogen. This carbon has 2 bonds, so I give it 2 hydrogens. This carbon has 2 bonds, I give it 2 hydrogens. This carbon has 1 bond, so I give it 3 hydrogens. And that is how you draw 2-methyl pentane. Okay, next one. Okay, the next one was 3-ethyl 4-methyl pentane. Okay, so well done if you got the first one right. It was quite easy. This one is much more challenging. 3-ethyl, 4-methyl pentane. So I'm just going to write the name down on the board before I take it off. Okay, so 3-ethyl dash 4 dash methyl pentane. Okay, right. So back to the board. Should see the board big now again. So step one is parent. Let's do the parent molecule. So here I am identifying the parent molecule. Happens to be the same one again, pentane. So an alkane with 5 carbons. So C, 5 carbons. And I'm going to number them now. So 1, 2, 3, 4, 5. Okay, step 2, branches. Branches. Sorry. I've got on carbon 3 an ethyl group. So I've got ethyl on carbon 3. And on carbon 4, I've got a methyl. Methyl on C4. Okay, so on carbon 3, let's stick an ethyl group. Here it is here. Ethyl is C2H5. Okay, actually I'm going to draw it out the full way just so you see what I'm on about. Okay, so we've got carbon 1, carbon 2. There's my 2 carbons. And how many hydrogens can I stick on? Well, this carbon has 2 more bonds to form, and this carbon has 3 more bonds to form. So hopefully now you can see why that is an ethyl is C2H5. C2H5. Okay, so that's your ethyl group. I've also got a methyl on C4. So I'm just going to draw it above C4 just so that it doesn't clash with this one. C1, 2, 3. There's my methyl on carbon 4. So last step 3, hydrogens. So just fill in the hydrogens. All carbon should have 4 bonds. 1, 2, 3. 1, 2. 1 above, 1 below, 1, 2, 3. Okay, so you should have hydrogens on all of those bonds. 1, 2, 3. 1, 2. 1 above, 1 below. That's a hydrogen there. And then 1, 2, 3. Okay, so that would be how you correctly draw that molecule. Okay, so again, really well done if you got that correct. That wasn't that straightforward. That was quite a tough one. Okay, I'm just going to go back to the screen to see what the next question was. It was chloromethane. So I'm just going to write this down here. Chloromethane. Okay. So for chloromethane, parent molecule is methane. So it's 1 carbon. Now, it's 1 carbon and it's an alkane, so it's all single bonds. And I've got a chloro on. Now, because I've only got 1 carbon, I don't need to say what number carbon it's on. It's on the only one that there is. You can draw it wherever you like. You can draw it on sticking out to the right. You can draw it up above. You can draw it to the side. It really doesn't matter where you draw it because it's still on carbon 1. So I'm just going to leave it there. And again, if you have got it on any other angle, any other direction, it's still correct. It doesn't matter. Okay. So that is the correct structure for chloromethane. Well done if you got that right. Okay, let's check the next one. The next one is dichloromethane. Dichloromethane. So for dichloromethane, di means 2. Just take off a hydrogen, stick on another chlorine like that. That's the correct structure for dichloromethane. Again, it could be on that out to the right, or it could be to the bottom, or it could be to the top. It really doesn't matter. As long as you've got 2 on carbon 1, because there's only 1 carbon, it's correct. Well done if you got that right. Next one is chloroethane. All right, a little bit more complicated, but should be still pretty straightforward. Chloroethane. So chloroethane, parent molecule, ethane. Eth means 2 carbons. Alkane because it's ethane, so single bonds, and it's chloroethane. Now again, you can stick the chlorine there, or can stick the chlorine there. It really doesn't matter because there are only 2 carbons and I can number from either side. So I can always make sure that the carbon that the chlorine is on is carbon number 1. I want to start, remember, with the carbon which will give my branch the lowest number. So if I stick chlorine on that carbon, then this is number 1. If I stick chlorine on this carbon, well then I number from this side, it's still chlorine number 1. So technically they're the exact same molecule. Then fill in the hydrogen. So I don't need a number here, it's just chloroethane. Okay, so that's chloroethane. Well done if you got that right. Next one is 1,2-dichloroethane. 1,2-dichloroethane. Okay, so it's 1, 2 dash dichloroethane. Okay, so again, parent molecule is still ethane, 1, 2 carbons. And we've got chloros, Cl on C1, Cl on C2. Again, it doesn't matter which side you number it from. Here's carbon 1 and here's carbon 2. We've got Cl on carbon 1, so here's my Cl. I've got a Cl on carbon 2. Here's my Cl. The rest are hydrogens. It really is that simple. 1,2-dichloroethane. Next one. 2-chloropropane. 2-chloropropane. A little bit tougher. For sure, this one's a little bit tougher. 2-chloropropane. Okay, so 2-chloropropane. All right, parent molecule, propane. Prop means 3. 1, 2, 3 carbons, and it's an alkane, so they're all single bonds. And on carbon 2, 1, 2, 3, I've got a chloro group, dash Cl. Rest are hydrogens. Fill it in, make sure all the carbons have 4 bonds. 1, 2, 3, 4, 5, 6, 7. Now, just as an extra challenge here, what I want you to do is pause the video and write down what would be the molecular formula of this substance. Molecular formula. That's a challenge. Pause the video so you can do it. Okay, you should be watching now if you've tried to write down the molecular formula of this substance. First of all, molecular formulas tell us the type and the number of each type of atom in the compound. So first of all, let's start with the carbons. 1, 2, 3 carbons. C3. Then the hydrogens. 1, 2, 3, 4, 5, 6, 7. H7. And then there's 1 Cl. Cl. Well done. You got that right. Excellent job. Last one. We've got one more here to do, I think. And that is this very last one, which is 1,3-dichlorobutane. 1,3-dichlorobutane. Okay, so for this one, 1,3-dichlorobutane. Okay, so for this, we're going to take the parent molecule, butane, alkane with 4 carbons, 1, 2, 3, 4. Then branches, we've got a chloro, Cl on carbon 1, and a Cl on carbon 3. That's what this tells me, 1 and 3 dichloro, so 2 chloros, 1 and 3. Okay, so number them, 1, 2, 3, 4, and on carbon 1, we've got a chloro. There it is. Carbon 3, we've got a chloro. There it is. Fill in the hydrogens. 1, 2. On this one, we can fit 2 hydrogens. And on this one, we can fit 1. And on this one, 3. And that is the correct structure of a dichlorobutane. Well done if you got that right. Again, pause the video. Try and write down the molecular formula of this compound. Okay, you should be watching the video if you've tried to write down the molecular formula of this compound. Let's show you how you do it. 1, 2, 3, 4 carbons, C4. Hydrogens, 1, 2, 3, 4, 5, 6, 7, 8. H8. And 2 Cls, Cl2. And that is it. That's all you have to do there. Okay. So again, well done if you were able to do all them questions. If you weren't, if you struggle with them, it's worth going back and doing it, because this is a really important thing you need to be able to do to answer the questions in organic chemistry. You have to be able to draw the compounds out, and you also need to be able to name them. If I give you this, you have to work backwards and find the name, like we did in the last lesson. So it's really worth spending the time. If you're still confused, go back and watch the videos again and do the practice questions again. But I hope you found that useful, and I'll see you in the next video.